Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 9 academic students who are looking for a bit more help as they prepare and study for the EQAO. It's video number 6 and this video focuses on the exponent laws. So we'll be looking at how to evaluate exponential expressions, how to do monomial multiplication and division, and of course how to simplify exponential expressions. So here's a first question. So what we're given is an exponential expression. In this case, it's a monomial with a coefficient 6, a variable x, and that has exponent 2. So we need to find the value of this expression when x equals 1/3. So we're doing a substitution, and we're substituting instead of x, we now have the fraction 1/3. So, and we know according to the rules of Bedmas, the first thing we do is we process or deal with that exponent. So if my base is a fraction and that fraction has an exponent, it means that both the top and the bottom of that fraction get affected by that exponent. So this is really 1/9 because it's 1 squared over 3 squared. So then now that I finally dealt with the exponent, I now have multiplication. So I'm multiplying 6 times 1/9. So if you're multiplying and a fraction's involved, then you multiply the numerator times the numerator and the denominator times the denominator. And of course, we would never leave a fraction unsimplified. So divide top and bottom by 3, and you get a final answer of 2/3. So remember, I'm just basically using the rules of Bedmas. I'm substituting a value for x, and then I'm remembering the exponent laws as they relate to a fractional base. So let's look at a similar question. It says, what is the value of 3x squared when x equals -4/3? So again, I have an expression, coefficient, variable, and exponent on that variable. This is a question asking me to do a substitution. And then we remember that the squared impacts a fractional base because it affects both the numerator and the denominator. Now at this point, I want to pause for a second before I even finish what I'm writing. And I want to make sure of something that is a common mistake but needs to be really well understood. And that is the difference between -2 squared and bracket -2 squared. So according to the rules of Bedmas, what I'm squaring here is the number 2, and then that number 2 is multiplied by -1. So this minus sign here really suggests some sort of, if you want, subtraction by 0, because this really says 0 minus 2 squared. So what's really important is that when you look at this expression, -2 squared, that you recognize that the base is the number 2. It's 2 that gets squared. The negative sign doesn't come into effect until I'm done with the exponent law. So the answer to this is -4. Whereas down here, -2 squared, well, this time I'm multiplying -2 times -2. So this time that negative does get impacted by the exponent. So -2 times -2 is +4. And the reason why it's so important that I bring that up is because if we go back to the question we're working on, so we have 3 times -4/3 squared. So I'm about to distribute that exponent to the numerator and the denominator. But what's important to remember is that numerator says -4, not 4. And so therefore this time when I distribute that exponent, I'm careful to keep this bracket. Especially when you're working with negative signs, a bracket is really important. -4 squared is 16. 3 squared is 9. Now obviously the hope is that you don't even need to write this middle step. That ideally you can go directly from here to sort of doing some mental math where you know that -4 times -4 is 16 and 3 times 3 is 9. So that's the sort of what we hope you're able to do, but I always put the middle step in just in case you're kind of new at this or you need to see some in between stuff. So now I have 3 and I'm dividing by 9. So instead of 3 divided by 9, let's make that 1 divided by 3. So I'm ignoring this numerator of 16 because really everything is just multiplied and divided at this point, and I'm simplifying the 3 over the 9. So my final answer would be 16 over 3. And I can pretty much guarantee you that an awful lot of people, whether they're in grade 9 or they're in grade 12, would get an answer of negative 16 over 3, just for the simple fact of forgetting about what happens to a negative sign when you square it. So be careful and look for that. So more exponent law. So this time it's disguised as a volume question, but it's really just an exponent law question. We know that the volume of a cube is length times width times height. It's on your formula sheet if you need it. So if I look at this, I have 2y times 2y times 2y. Now, of course, I could also write that as 2y cubed. So it's not exactly coincidence that when I write exponent 3, I say cubed, and it's basically because of what happens when you look at the shape called a cube. So that means the volume is, well, here, again, don't forget that that exponent 3 impacts every part of this bracket. So it's really 2 to the 3 and then y to the 3. So you should get that the volume is 8, and then I'll have y cubed. And up here you can see that I would still get that if I just do multiplication instead of exponent law. 2 times 2 times 2 is 8. Y times y times y is y cubed. Okay. So now we do some division. Simplify the following algebraic expression. So remember that when you're dividing, the exponents are subtracted. So I have a to the 6 minus, or divided by a squared, so that would be a to the 6 minus 2. And then b, well, this b is really b1, so b to the 4 minus 1. So that would give me a4, b3. Hopefully you find a question like that really straightforward. And here's another question that kind of combines exponent laws with our understanding of other parts of the course. It says expressions for the base and volume, the base area and volume of a prism are given below. What is the height? So volume of a prism is given to you on your formula sheet as area of the base times the height. So you know that it's given on your formula sheet, and we've talked about it in class, that if you have a base like this, then its height is a third dimension that gives you volume. So volume equals the area of the base times the height. So if I look at the information I have, I know that 64a cubed b6, that's the volume, is equal to the area of the base times the height. And I'm going to use h for height. So obviously, if I want to find the height, I have to isolate the variable h. And if I'm multiplying by 16ab cubed, my next step is going to therefore be to divide by 16ab cubed. So on both sides, I divide by 16ab cubed. And then here, I'm left with equals h. So how do we divide? Well, we look at the coefficients and we do division. 64 divided by 16. Now, if my answer was a fraction, I would leave it as a fraction, but 64 over 16 happens to work out perfectly to 4. Then I have a cubed over a1. 3 minus 1 is 2, so that's a squared. Then I have b6 over b3. 6 minus 3 is 3, so that's b3. So this must be the height in order to give me the volume. So that's a good example of dividing using the exponent laws. And I think that's all the question I found for us. Oh, wait, one more. Of course, if you're my student, you've seen this question 100 million times. It says Meg has been asked to determine the value of the numerical expression below. What is the value of Meg's expression? Now, the reason why I really like this question is because of the number of times students will say, Miss, this doesn't fit into my calculator. I get an error message. And my response, of course, is, I know. That's the point. And the point is that this is not something that I want you to punch into your calculator. It's something where I want you to know the exponent laws. And by knowing the exponent laws, you can then do this question. So over here, I'm dividing, and the base is 2. So we know that if you are dividing and the base is the same base, then you can subtract the exponents. Oops, that was a 3. And so that's the first step of this question, is to subtract those exponents and get 2 to the 4. Now I can say to you, yes, Now you can do this in your calculator, although hopefully you won't need it. 2 times 2 times 2 times 2 is 16. And here 2 times 2 times 2 is 8. So 16 take away 8, and the answer is 8. Again, it's a really nice question in my opinion because it involves you understanding a law and not just relying on what your calculator tells you. Okay, so again, if you are one of my students, you've seen this question about 12 different times, but hopefully, no matter who you are, it makes sense. Yeah, that's the last question I have for you on exponent laws. We certainly spent a lot more time in class on it, and it's something you do have to know. However, I would say that the EQAO tends to ask maybe 2, at most 3 questions involving exponent law. So just keep that in mind. It's important that you know it. Don't not study it, but remember that it's not heavily emphasized on the EQAO, but it's very important for grade 10 and 11. All right, I hope that video helped, and I will see you study somewhere. Bye.